lesson, I am going to explain you assembly language programming and machine language programming of 8085 microprocessor. Means this programming is very useful for experiment purposes. So here 7th given comparison of two hex numbers for equality. It means we have to compare two numbers which are present at two different memory locations, and we have to compare whether those two numbers are equal or not. Okay, the microprocessor will check, okay, that whether those two numbers at those two memory locations are equal or not, and if equal, then what we will get the result, and if those two numbers are equal, then that number it will come in the output. Okay, it means we will say that at the memory address where we need to check the result, and if those two numbers are not equal, then in that case we will see that at the place of result, means the location of memory where we get the result, there we will get 0 0. Okay, so this is very easy uh, programming. I think most of the programs are easy, but here you have to think, you have to imagine how processes, process information, how, what are different ways. So those things we have to think. The subject is quite interesting. Okay. Okay, now. For comparison of two hex numbers, the first instruction here is given LXI H2012. So 2012, it means we are loading 2012 in HL pair. So what it does, it loads HL pair 2012. Okay. So whatever in HL pair, that it acts as memory. It means we can write this M. Okay. It means we made this location as memory, and now from now onwards, whenever we say memory, it means it refers to memory location 2012. Next instruction given, move A comma M. It means moving the content of the memory to the accumulator. Okay, so memory here it is this one, and at this location I have saved, for example, 1A. Okay, here I have saved 1A. So 1A it will move to the accumulator. So here we will get in the accumulator 1A. Next instruction given, INR L. So increment L register, only L. Here it is HL pair given. So only L means here 2012. So this 12 it will become 13. So okay. So we can use here INX H also. Same thing we will get in the result. Because if we use INX H, so HL pair will be incremented by 1. So here you can use any one. So here in this program it is written INR. So that's why I have also written that. Okay, because earlier we have used so many times INX H. So this time I have used INR L. So that you people can get familiarity with different instructions in the microprocessor, that is 8085. Okay. So INR L given. So when this instruction execute, then we get here this becomes so when it happens, then L will become 13. So L, what you will get here, L will become 13 incremented by 1. Okay, so if it is 13, so HL pair, so it means we can say the HL pair we will get 2013. It means this is nothing but memory. What is this? Memory means from now onwards when we say memory, it means it refers to M. Okay. So the next instruction, that is CMPM. So what it does, this is compare the content of accumulator, compare. Okay, CMP, it compares the content of the accumulator with the content of the memory. Content of the memory meaning 2013. Okay. So for example, if I take here at this memory at 1A only. Okay. So it will compare, and also this way means this instruction subtract means it subtract the content of the accumulator and the content of the memory, and the result it saves in the temporary register which is present in microprocessor. Okay, the result we get in temporary register. Clear? So in temporary register we get if both same, if here also 1A, here also 1A. So in temporary register what we will get? 0, because difference we will get 0. Okay. Then after next instruction given JZ200F. So JZ means when jump if 0. So jump if 0. So this instruction it is checking the condition, means this one it is checking the content of the temporary register. So temporary register here which we as a programmer cannot access that particular memory, that particular register. We cannot access that register. Okay. So here JZ jump if 0. So since if same number at accumulator and at memory location, then in that case we will get 0 0 in the temporary register, and then it will jump to this location 200F. So where we have 200F? This one. Okay. So it directly jumps here, and then from here it will execute. Okay, from here the next instruction it is INR L. So these three instructions are not going to be executed by the processor, or you can say these three instructions are not going to be processed by the processor because here condition given. Okay, so since we get 0 here, so that's why it will directly jump to INR L, and when it jump directly to INR L, so it is going to increment on the L register. So L register here you have 1 3, so at this place you will get L equals 1 4. Okay, you will get 1 4. It means there is no change in L register, so that's why you will get here 2014. Okay. Then next one given move m comma a. Move m comma a meaning moving the content of the accumulator to the memory. So here memory we have, so this one it is HL. Okay. So this one it will act as memory because this address it is stored in HL a register. So that's why move a comma m, sorry m comma a, and moving content of the accumulator to the memory. It means what we have in the accumulator, you see 1A. So this 1A it will move to memory, that is 2014. Okay. So this one you will get m, that is 2014. At this location it will come 1A. Okay. So that at 2014 we got 1A. And then the next instruction given RST5. This instruction it is used to you can say this is a kind of subroutine. I mean, say it just send the processor to process. Simply, you can say this instruction sends the processor to a subroutine, which ultimately leads the processor to stop further processing. So here given 1A, so this one, this is the result. This is the result location. Okay, this is the result location, and this one is the first number. You can say this is first number. First number, and this is second number. Okay, this one is second number. So these two numbers when compared, and the processor found that those two numbers are equal. So that's why we are getting at result address, that is 2014, the number 1A. Okay, this one when two numbers are equal, and when two numbers are not equal, in that case what will happen? Okay, now come here. If here it is not 1A, so for example if it is 1B. Okay. So since these two numbers are not equal, so in that case, this is next instruction, that is compare m. So compare M means it compares the content of this memory 2013 and the content of accumulator, that is 1A, and also subtract these two numbers and save the result in temporary register, that is temp R. So in this case, when there is subtraction, then in that case in the temporary register we will not get 0, we will get some value. Okay, so it is not 0, it will not equal to 0. Okay, since temporary register is not equal to 0, in that case jump, next instruction given, jump 0, jump if 0. Since it is not 0, so it will not jump to the address this 200F, and it will go to the next instruction. Okay, so this time it will not jump and it will go to the next instruction. So next instruction, that is INR L. So again increment this one. So L here it is 13. So this one will make L as 14. So we will get HL as 2014. Okay. Then after MVI M00. So now you have to see that how many. Now you can see here from 2000 to 2003. That means this instruction is 3-byte instruction. So according to the address, means how many memory locations one particular instruction is taking. By that we can determine that that particular instruction is of how many bytes. Okay. So since this one is taking 3 memory locations, so this one is 3-byte instruction. And now you see here, so this one, yes, this one, this is taking 2 memory locations, so that's why this is 2-byte instruction. By analyzing the memory locations taken by that particular instruction, we can determine that that particular instruction is of how many bytes. Okay, now here MVI M00, it means we are moving 00, we are loading, you can say, or it is moving 00 to memory. Memory meaning here, that is 2014. So by that we will get 2014 equals 00, we are moving. Okay, next instruction given, JMP jump 2011. Okay, it means directly jump to 2011. So jump to where it is 2011, so this one it is 2011. So it will not process this instruction, and also these two instructions are going to skip by the processor, because this instruction directly jump this to locate memory location, that is 2011. And here this instruction it is RST5, that is again I have already explained so many times, that is a kind of subroutine instruction which sends the processor to a particular memory location, that is 0028H, and where the processor doesn't find any instruction or any instruction to process further, so that's why processor ultimately stops. So that's what it happens here. So this is the whole thing. So when it is move 00, so result, what we are getting result here? Result. So when numbers are not equal, we are getting result at 201400. And when numbers are equal, in the earlier case, the result we are getting is whatever it was the number that it is saved at that result memory address. Okay. This one it is assembly language programming, and if we want to program using machine language, again we have to use machine code, that is hex code, and for that corresponding whatever instruction I have used corresponding to those instructions I am going to use hex codes. Okay, hex code, or that is also called opcode. So here the first that is given LXIH. So for this one we have 21. For LXIH we have 21, and here for the address again LSB we write down first. So 1, 2, then after 2, 0. Okay. Then the next instruction given, move A, M. For this we have opcode or hex code, that is 7E. Then after next instruction means for INRL, the hex code or opcode, it is 2C. For CMP, we have BE. For JZ, we have CA, and for the address we write LSB first, that is 0F. This is LSB, and then after MSB write that is 20. Okay. Then next instruction again INRL. So whatever here hex code, the same thing here it will be, that is 2C. Then next instruction, that is MVI M00. For MVI, the code here it is 36, and for this content, this one 00. Okay, this one I have written here, and for this MVI we have code 36. And next JMP code, it is C3. Again we write down the address, first LSP, that is 11, and then after MSP, that is 20. And again INRL, same code we will use, INRL, that is 2C. So 2C, move M comma A. So this one it is A comma M, here M comma A. So for M comma A we have different code, that is 77, and for RST5 we have EF. So whatever I have written in red color, so those are corresponding hex code or opcodes of all different instructions which I have used in this program. It means when you are going to use opcodes, or that is known as operation codes or hex codes for programming the microprocessor, then that it is machine language. That is machine language programming. And when you are going to use mnemonics, okay, then that it will be called as assembly language programming. So you can use any one of these two to program the microprocessor in microprocessor training system.